Welcome back, everybody. I hope everybody's doing all right. So, what's going on today? Yesterday we started trying to solve the problem, which was asking the user for input, and we started having a look at the Ratatouille GUI, well, TUI Rust create sort of allows you to create terminal sort of applications, console UI, as they're called. CUIs, TUIs, GUIs. There's a lot of names for all these things. Anyway, so I said at the end of yesterday's stream that I need to go away and look at it and decide, learn more about the architectures and so on. So one of the things that we were looking at yesterday was where are we? Yeah, various different architectures that you could possibly have. So you've got different application patterns. You've got Elm architecture. Let's have a look. Switch over to this. There we go. We've got the Elm architecture. We've got component architectures and Flux architecture. Great. Fantastic. So I did quite a bit of reading. Decided that I liked the Flux architecture pattern more than the other ones. But there's not a lot of information on how you go about building one and so on. And it still needs more research before I can choose one of these things because it's a rather large decision. I also did a bit of digging around between, well, should I really be using this Ratatouille or should I really be using cursive? Cursive's the one that looks like this. We had a quick look at this the other day, but what I didn't find the other day was that there was a little comparison page on the cursive GitHub. And what it says is that cursive uses a more declarative UI. The user defines the layout and then the cursive handles the event loop. And this is one of the things we found yesterday is that Ratatouille just doesn't have any sort of input handling itself, and you have to basically get all the events and so on from Crossterm or your terminal backend. Because where we were getting unstuck, it's like, well, how do we write a test for all this kind of stuff? Cursive handles all the input, mouse clicks and so on, and it's got this concept of views and all this kind of stuff. Which, to be honest, now that I've looked at it in a bit more detail, it's more like what we actually need. But the situation is complicated further by the fact that if you try and do search for like cursive and Flux architecture, you don't find a lot of information. So I'm like, what? Does it make sense to do it like this? I just don't know yet. So I was looking at GUIs, that Rust-based GUIs that might possibly be able to use Flux-based architecture. And I've not found any decent solutions or ways of it working or nice examples. What's all this Flux stuff? Let's have a look. Yeah. Oh yeah. Here we go. You're all going to enjoy this logsec. So for this project, I've started creating a logsec log, and we're making various notes and so on like this, and we're creating graphs, and then we can access these things and search for them and whatever. And I'll probably make this available to Patreons at some point. And yes, we've got our first Patreon, so woohoo! Thank you, Patreons. I don't know whether to have a list of names or something at the end of the streams at some point. I'll probably try and sort that out. Okay, so Flux, yeah, Flux. Let me try and pull this out onto an. When I click these, it opens it in the wrong browser. Let me bring it up in the right one. Not that one. Hold on. Come on. Here we are. Yeah. So this is what I was used to when developing GUI apps, and yeah, if anyone's done GUI apps or like web-based apps and things like this, they know all too well about this. Is that you make a change in one model and that model has got a view associated with it, and it needs to update from the other view, and then there's this two-way data flow thing going on, which causes like an event nightmare, and you get these funny conditions like which one happens first, and then if this happens, does it cause this one to update? And then it's just a nightmare to debug as the application scales. And I've been there, I've done that, and it's 2024, and we should be looking at better ways of doing things. So apparently there's this Flux architecture, which has a single directional data flow, which I found very interesting. So the idea is you have an action, it goes to a dispatcher, and then it has a store, and then the store creates things, and then you get a view, and then you get some event, and that ends up creating a new action, and so on. But it always goes in one direction, and there's a determinate, and you can determine the order of things by the order that they're registered with the dispatchers and so on. I don't know too much about it yet. It's very early days. So yeah, but there's lots of interesting articles on this, which I need to sit down and grok and fiddle around with and play around with really before I commit. So, and then I'm like, well, okay. So one of the things that we want to do is, have an actual graphical user interface for this at some point. Where you can click on the things and then select them with a mouse, and that kind of stuff. Or maybe use touchscreen, select and resolve things that way, right? So I also looking around, so it's like, okay, well, what graphical user interface is written in Rust to use this flow thing? And then you've also got this architecture thing where you can detach the data and the processing of the data from the user interface, which is an architecture that I like. Let me go back to the architecture thing that we drew. Yeah, this. If anyone remembers this from the other day, yeah, that. Where are the boundaries? Where are the UIs and so on like this, and yeah. So if we've got a user interface and it's using a store, which is kind of similar to what you have for integration with parts as well. So you would have sort of inventory parts store. So it sort of fits well, this flux. At first glance, this flux thing seems to fit well with where I want to go with this long term. So I need to sit down and have a look at it. There's some interesting examples floating around on Tinternet, with regards to this cursive stuff. One of them is this rusty chat thing. Was it this one? No. No, not that one. Thinking of a different one. Have I lost it? Can I find it now? No, maybe it was that one. Hold on. I was just looking at some code earlier today. Let me check the history. It'll tell me where it was. This one. Here we go. This. Rusty chat. Let me find it again. Chat. Oh gosh. Oh, okay. Let me try and find it again. I could have sworn it was this. This, yes. This is one. So yeah, this uses the flow architecture, this little UI program. And the way that it does it, I found quite interesting. I was having a look at this. I need to grok a little bit more of this. But it's the way that it's laid out is very interesting. But it's somewhat tricky to grok all of it quickly because it uses Tokio and some other concepts that I'm not entirely familiar with. But basically, it separates the display of all the chat information and handling the keyboard, and then it sends all that information to a server, which then processes that and updates state and does whatever it does. And then if someone else types into the message from another place, then it sends you back a message saying, oh, there's a new message in the channel, and then you receive an event, and then the view gets updated, right? And this sort of client-server approach to creating this user interface probably fits well with this long-term sort of architectural goal that we've got, where we've got this UI planning thing, and then we've got this other thing which sits around and does whatever it does. And then the idea there is that you could have different interfaces for this, depending on the needs of, well, either the machine or the planner or whatever. So interesting. So yeah, so more research required. More research required. So where do we go then? Where do we go from here? Because let's jump back to the code and try and remember what immediate problem we were trying to solve. And we'll see if we can make any progress on this or not. So the problem we're trying to solve is that when you're going from a EDA file and you want to create a job for the machine, you've got to resolve the components that you want to use somehow. And we've got one way of resolving a component if there was only ever one thing that it could resolve to, which is fine. But in other cases where there's nothing it can resolve to, or there's multiple things that it can resolve to, we need to ask the user. But do we? Or do we just fail and just go, no? And then if we say no, what is the user expected to do? How can they get themselves out for this if we don't have a GUI or TUI that we can interact with, because we're not in the position really to start writing one because we haven't worked out how we're going to, what technologies we're going to use. We haven't decided that. So can we make any progress on this? I think we can make some progress on this. The way to make progress on this is delete this. Problem solved. Right, there we go. Easy. Easy. Okay, but then what are we going to do? Okay, so let me just put that back there for a moment. So we've got some other changes floating around here. I don't think I want any of these things right now. Let's just quickly review the changes that we had yesterday. So we start adding in a console UI, and we started creating, copying and pasting from some example, and we started fiddling around with all this stuff. No. Displaying placement mapping confirmation we added to the test, and we added some depend. No, don't want it. So what we're going to do is not that. We're gonna check out -b Ratatouille work in progress. No. Experimentation. 1 work in progress. Well, 1, that's fine. Okay, and then we're just going to commit everything to that. and it's going to be fine. We're just going to go, whatever, work in progress. Wait. I know, maybe we come back to it, maybe we don't. So let's go back to where we really were, which is here. Okay, we've still got this to do, so let's not do it. Done. What do we need instead? That's the question. What do we need instead? Well, who's got any ideas? So what we came up with, if you remember yesterday, is let me try and locate things. In the part mapper, we added some code. Yeah, this was it. This bit. This was what we added yesterday to allow us to get to this point where the auto selection rule was applied. So we've got a rule, and what I'm thinking, I don't know. I'm literally thinking about this now, as I'm saying it. I don't know. What about allowing the user to specify some rules on the command line? What about reading some rules from a CSV file? Okay, either of those things are fine. What would a rule look like? Let's go back to the test, have a quick look. So obviously there's no way to resolve this because nothing matched to it. So there's nothing that you could specify that would fix this problem anyway. What's the user expected to do at this point? The user is expected to create a new mapping. Fine, the user goes away, creates a new mapping, runs the tool again. Problem solved. We didn't need to add anything to the code base to do that. This one is a bit more tricky, however. This one's a little bit more tricky. And we have some ideas around this. One of the ideas around this was use whatever's in the pick and place machine already. There's a thought. What's in the feeders? Are we at the point where we have a list of feeders and state of feeders to say they're loaded in the machine, right? And can we look at them? And then have a rule that says use the ones that are in the machine. Because that's what I want. And that's what I had before. Let's just remind everybody of the previous project that I was working on. So PnP convert, that one. Right, so the way that this worked, do I have the examples? Yeah, should be. Is it going to work? What do we think? Oh, no. Okay, yes, it's fine. This is what we had before. We zoom? Well, we can zoom. I don't know, you can zoom with the control key in Excel, but there you go. So this is just like an example for PnP convert. And this basically said, I've got this part and this manufacturer thing in it, and there's an ID for the feeder which corresponds with the number on the side of the feeder on the machine, and whether it is enabled or not. Right. So sure, we could have a list that looks a bit like this, can't we? Let's let's remind ourselves what OpenPnP has. Since, this is one of the sources of inspiration for this, amongst other bits of software, including the Charm High stuff. Let's bring up OpenPnP. So in order to do that, IntelliJ. Oh, not this. No. That's OpenPnP. There it is. OpenPnP. Go. Yes, we do. Let's see if we can run it. So I know what I had before, and we can have a quick look at what OpenPnP has, and then we can have a quick look at, say, the Neoden software. Is it running? There it is. Okay. So OpenPnP has this concept of feeders, and a feeder has like a name, and it has a part that's in it, and you can change what part is in it by selecting it and then clicking apply. Right? This is how OpenPnP works. So we've got this concept of a part already. And our part is like a manufacturer and a part code, right? And we've got this concept, well, we don't have this concept of like a feeder name yet, or identifier. But yeah, so that's what that has. And let's have a quick look. I think on YouTube at MakerPnP. Why did it bring that up? That was weird. Why did it bring my Firefox settings up? What? YouTube MakerPnP. Press return. How did it? Why? That's weird. It's done that twice on stream. Anyway, so create playlists. Live streams and Charm this PnP software. This one. Let me mute that. Neoden. Oh yeah. Someone shared this with me the other day. This was interesting. Huh. Is it Neoden 4? I think there's a Neoden 4 detailed tutorial. This one. This is supposed to be on my list. Let me add it. PnP software. There we go. Right. So we can see from this. Let me try and zoom this in. Can we zoom it in? Can we make it bigger? Cinema mode. Yeah, we sort of can. All right. So what we can see from this is there's a list of components, but I don't think that's what we're after. We want to see what's in the machine. Yeah. Oh, wait, hold on. Yeah, it's not pretty, this. You're right, here. It's got a definition of a list of feeders, and then somewhere here on the right you can say what's in it. Sure. Let me see if I... Wait, was that him doing it there? Let's see if we can just find it real quick. How do you change it? We care, but not that much. The exact usage of the software. But basically there's a way of specifying the feeders and then what parts in them, right? So, all good. So let's define a feeder. Sure. And then let's create a rule that says if you've got this feeder and it's got this part in it and the feeder's enabled, then use it. It seems like a reasonable way of proceeding instead of writing a console UI app right now. Okay, so we're moving on. This one. Righto. Okay, so what we're going to say is already, well, let's say, yeah, I'll type this in, and then if we want to change it later, we can do it. Already in, what was it? No, here we go. Found in feeder. And I guess we delete this, right? Because there's not going to be an error anymore. Do we want that? Okay. Found in feeder. That's what we've got to do. So somewhere in here, we've got to go, well, if there's more than one, then look to see if there's one in the feeder. Okay. How's it going to find the feeders? We've got a CLI tool right now. It's going to find the feeders. Good question. In the same way that it finds the parts from a CSV file right now and some other way in the future. How about that? Yes. Yes, this seems fine. Like, because we don't really sort of know or care who is the, or what should be the authoritative source for what's in a feeder. That's an interesting thought. Do we even need a feeder yet? Oh, that's an interesting thought. Do we actually just need a feeder identifier and then the details of the part that's in it, rather than defining a feeder itself? I think that's probably what we need. So essentially what we've got is a feeder loadout. And then the details of what's in the feeder, how all its vision settings are and its vacuum settings and all this kind of stuff is, that's part of machine land. But we're not in machine land, we're just in loadout land. And what we need to do with this is separate these two concerns, because we're not dealing with the machine just yet. We're trying to get ready, have something that the machine can use, and then the machine's going to go and do it. But we're not there yet. We're not there yet. So we don't want to define a feeder. We want to define a feeder loadout. So let's do that. Let's do that. Okay. Let's try it. So if we said, let's go back down to our build. Yeah, this, right? So if we said there's going to be a loadout file. Is loadout hyphenated? Yeah, I suppose it is. I.e., what's in the machine? Is it hyphenated here? Well, we did this one and then that was done, so I guess it is. Anyway, we can always come back to it. So we're going to make it do that. So let's make it do that. Let's make it take an argument. Yeah, this seems like a fairly reasonable way of progressing. Okay, so we've got a build command and we've got parts defined. So let's And I guess if you don't have a loadout file, then you'll get a mapping error, right? Seems okay. Oh, so is this optional? I suppose it is, isn't it? Hold on then. I don't remember what this is going to look like. We had this thing with this, didn't we? We had this trace, and then you got a trace file. And trace was optional. I'm not sure exactly what this is gonna look like when I define what we actually want, because we're at the mercy of clap. So if we say loadout file, and we say load, because that's how it does it, and it's a string, but it's not a string. It's going to be a option string. There's actually an issue here because we've said file here. At the moment, it does want files. I guess when we add support for something that's not a file, we can come back and change it. Yeah, no, that's fine. A thought that just went through my head is that we've got string there, but we could actually specify path buff there, like we did for the trace thingy argument. We specifically said path buff there. Okay, so fine. Loadout. So let's run this and see what happens. Let's see how the test fails. Right, so we've got a concept of a loadout, but we don't have it here yet. So there's quite a lot of things going on here. Gonna need this. Sure. Okay. So let's run it. And here I was thinking I was going to create fancy little ANSI, ASCII, GUI, TUI, CUI things. No. Not today. Not this week. Not this week. Because it's Friday. There's a beer festival near me today. I'm going later. We'll see how that goes. It's gonna be interesting. Right. So yeah, okay. So, oh, well, that was interesting. Look. Something a bit wrong here. Like, what happens if you run build without any of these options right now? It feels like, okay, because some of these are required arguments and some of them are optional arguments, but it's not clear from this which ones are which. So we'll have to come back and review that. Yeah. Okay, fine. So, we've got an argument and we pass it to the build assembly variant method. Happy days, but we don't do anything with it yet. Right, and it's failing for the right reason because found in feeder. Okay, now that we've got this phrase for this called loadout, we could probably change this to say found in loadout. That probably makes a bit more sense now. Right. Okay. Fine. So we've got this, and it's an optional string. Let's try and do something with it. Well, I suppose we've got to load some loadout like we did before. But in order to load some loadouts, we need to have some loadouts defined that we can load. So back to the test. What does a loadout look like? It's going to be fairly simple, really. I'm just wondering which one to start with and copy. So we've got this. We've got placements. It's not going to be the same as that. It's probably going to be closer to parts. Yeah. So what we're going to do is steal all this. No, not that. This. Here we go. This. Then we've got part mapping. So we'll keep the part mappings and everything else like that separate. An expected part mapping tree. Let's put it above that. Yeah. So copy it. Paste it in here. I wish you could paste and then have it select what you've just pasted automatically. Comment out. Oh, did I? Am I commenting out the wrong bits? Yeah. Okay, so we've got this placements. Yeah, this is another interesting technique with this given, when, then, and stuff. You put little messages there to say, you know, what the block is relating to, and parts, you know, and then we've got stuff to do with parts, and then and part mappings, and then you've got stuff to do with this, and whatever, you know. Right, so we're back up here. So we've got this parts path bit. So if we search this chunk for parts and then replace it with load out. Oh, there was another one that I missed. You guys didn't tell me. Another one, and there was another one in front of it. Oh, but here we've got this, and then our help thing said with a dash. Fine. So we want to load out arg for sure, and we need to use that argument. Let's add it just here. Load out arg. Okay. And we're going to flush a CSV file. Oops. I'm commenting the wrong bit. Oh, editor mishaps. Right, so we're creating a new CSV file. What's going to be in the CSV file? I don't know. But first we need a writer. So we need to create these record things. We've got these part records. Which looks like this. So we'll start with one of these. And let's start with a structure definition. And it's definitely going to have the same two things in the loadout, which is going to be the manufacturer and the manufacturer part number. Because otherwise, how are you going to match it, right? So it's going to need that. Yeah. Right, and then we need the same serialization stuff, right? But do we need anything else in that yet? No, not yet. We do have this concept of like enabled and disabled. Um, Sometimes you keep a part in the machine, but you might not want to use it, so you disable it. um, but we can add the basic stuff first, and then add the support for enabled to disabled things in a loadout. Right. Curious. Curious. What else? What else do we need in a loadout? Do we need anything yet? Because we don't have the concept of a feeder yet. I think probably for completeness sake and for no other reason, and we're going to probably get a warning forever because of this, we should probably have a reference value here. That's what I'm thinking. So for my machine in the other room, the reference might be left 7. Right? Or if you've got a 3D printed blinds feeder or something like this, or just like a strip feeder or something like this, it might be called plastic tape thing. Oh, I've got a telephone call. I shall come back to that. Give me just one moment while I respond via a text message. Sorry about this, people. Life. Probably people trying to arrange the beer festival for me this evening. That's probably what it is. Righto. So yeah, some kind of reference, string-based reference, is going to be sufficient for now because then at least we can print out the reference. Okay. So we're going to use those here, right? And I'm going to uncomment all of these and then delete all of them except one. Oh, I deleted the wrong ones. Okay. Right. So what we're trying to do is pick this one because it's found in the loadout. But I'm going to change my mind and not use this one. I'm going to make it be that one. My thought there is that I don't want it to be the first part that it came across. Like, how could it fail? Resistor manufacturer 2, resistor 2. That's what we said, right? Yeah. Found in loadout. Reference. Ta-da! And now we've got a reason for the reference. So that'll work. That'll work. And now we won't get some warning saying, "Oi, you haven't read this." Test part record, test loadout record. Reference. Yeah. What's our reference going to be? What's our reference going to be? let's just say feeder 1. Why not? So that means we can print the reference here. There. That looks good. Yeah. Yeah, by making it the second one, we're going to have to like force iteration and things like this. If it was just the first one, you could just get away with dot first or something like that in your production code and it would still pass. And then you would need another test to make sure that it worked somewhere else in a different position in the list. Obviously, you would test all this at a more fine-grained level with a bunch of unit tests and not the integration tests like the ordering stuff. Okay. But you've got to start somewhere, so we're starting there. Right, so we've got test loadout path, we've got loadout, we create it, we save it to a file, so it should fail with for a different reason now. Perhaps. No, it might actually fail for the same reason. Because it's not yet looking at the loadout file. So we wrote a loadout file, which is good. And didn't find it, basically. Perfect. Okay. So now we can load some loadouts if we've got a place to get them from. Since it was very similar to the parts, we're going to steal this. Ooh. A thought occurs. I know it's dangerous, isn't it? Let's say loaded 1 loadout. Item? Is it loadouts? What are the things in the loadout? I mean, let's just say loaded 1 loadouts. It's a bit weird. But okay. So we need to say that, and we said that we're going to do it after the part mappings. So here's the part mappings, and then we've got the assembly variant, so we're going to paste it here. See, loadouts doesn't seem right to me. It feels like it should be a loadout items or loadout entries. Because a loadout is like a plural thing by itself. So saying loadouts, it looks like you've got 2 lists of something. Yeah. Loadout things. No. Entries. But that it's sort of overloaded in that you have like a hash map and a hash map. One of the things in a hash map is called an entry. Items. I'm going with items. There. So now we can load it, and it's going to still be a vector, and this vector can be completely empty, which is perfect. And then we're going to say load out. Oh, that's interesting. Load items. It's a bit different to the other ones, isn't it? It's funny how that works. So we don't have this. Oh, it's using the wrong one. This is supposed to be loadout source here. Okay. So we don't have this. So the other thing that we had was this, which was in our loaders here. So if we go back to this mod and create a pub mod load out. A file. Yes. Okay. Now we can go back to where we were. And we can, honestly, and import it. And then we can create the associated function. And then we can refer to the parts one. We get the return value right. Because it's going to be the same as the other ones. So it either works or it doesn't. And if it works, you get a vector of loadout item. Or you get an error. Cool. So we have loadout source here. And we've got this concept of a loadout item now. So PnP, we've got a part, we've got a placement, and now we're going to have a loadout item. Okay, and if you remember, it has much of the same things that a part has. So we're going to steal this. And it's going to have the additional reference string. And everything's fine. So that's pretty much it for that. And at some point we'll write some code to use it. So now we can import this. Right, now we're going to need to deal with the whole sort of records and all this kind of stuff in the production code to deserialize these things. So we'll refer to the parts loader. And this is what it did. And honestly, it's pretty much going to be the same as this. But maybe there's some differences. We'll find out as we go along. And we're going to schlep it in. Comment everything out. Search for part. And we're going to search for part. Oh. Case sensitive. That's going to be that. And then we've got the part. What happened there? Oh no. Press return. So we want to return to load out. We're going to call this load out items, because this is what we said. Or just items, in fact. Okay, seems reasonable. So we're definitely going to return some. And we need some. It's going to be empty. Loadout. This needs to be a loadout item here. And then we're going to create a path buffer from the source. We're going to get a path from the buffer. And then we're going to create a reader using the path. That all seems fine. Then we're going to iterate over the CSV reader and we're going to get records from it, print them out, trace logging. And then if there is one, when you try and build it, you add it to the list. Otherwise, you say bail to do. And at some point, we're going to have to come back and fix all these. Because we've not dealt with like errors in CSV files and so on yet. But now that these loaders have been extracted into the loaders module, I keep wanting to say package. Now that they've been extracted into the loaders module, it makes it a bit easier for us to write some tests for these. So we'll do that at some point. So we're missing the loadout record now. And we have part mapping records, and we've got all these records in this CSV thing, right? So there should be a part record somewhere. There it is, with a build part on it. So we're going to copy this and schlep it in underneath. Comment it all out. We're going to start with the structure. And this is going to be loadout. Should we be using loadout item record? I think we should be. Because then at least it's consistent. And it has the manufacturer part number, and it's also going to have the reference. And it needs to be deserialized using Pascal case. Fine. And then what we said was we need to go build loadout item. So we need an implementation. For this, which is going to look like that. In it, it's going to have this method, which needs to return one of these loadout item records, which is going to contain the manufacturer and the manufacturer part number, but also the reference. But we've got the signature wrong here. We said we're supposed to be returning one of those. We've got part here still. So yeah, all right, fine, right. No. This doesn't return a record. It returns a loadout item. Take a record and yeah, duh. They're like that. So we can load items. Probably. Not yet, we can't. Let's not make this an option here. Let's make this the same as the other thing. Let's go match loadout source some source, and then use the source like this. And then all our loaders have a similar sort of API, which will make later refactoring better. And if there's none, we're just going to return a vec that's got nothing in it. But the compiler's going to be a bit unhappy about this. No, it's going to return an OK one of these. And it should be able to infer the type because we did this one. Let's find out. Otherwise, I'm going to get all turbo fishy. Okay. Part record. What? Oh, yeah, well. Yeah, we can fix that. Now, what's this? Don't need part either. Fine. Go again. Another unused input. Where? Okay, well, I'll delete it and see what happens later. Fine. So, yeah. Okay, it's good. It loaded it because if you remember in our test, we said loaded one loadout items. We should find that somewhere over here. Loaded one loadout items. Ta-da! That was good. Worked first time. I love it when things work first time. That's great. So now what? Now what? Well, we've got this part mapper thing, haven't we? This. And this is where we need to make some changes. But it doesn't know anything about loadouts or anything yet. We've got our loadout items, but we don't do anything with them. We don't need it for the assembly variant processing, but when we process stuff, we need to give it the list. So we'll give it the list like this. Okay, right. So what have we got here? This is good. So when there's a one-to-one relationship between each of the things, you don't need yeah, temporary reference. So it's a bit funky. We don't need anything like that. We don't need to use it. So we've got to make these old tests work, and then we're going to have to write a new test. Right. That should fix them up. Thus, they still pass. This is good. And it says unused variable X. Not even supposed to be called X. This is supposed to be loadout items. Right. So now we can use it. Oh. Now we're not going to be using any kind of part mappings because the part mappings was to go from EDA to manufacturer and part number. But our loadout already has manufacturer and part number, and our part mapping will have had the right thing that we need. So at the moment, it's got applied rule none. where do we want to add the additional part mapping rules and so on? We said here, so my first thought is to stick it there and see what happens. But it may be that we want to do the rule processing stuff as a sort of like a separate thing. I don't know. Maybe not. Like, do we just want to go apply rules and then away you go? So we've got to deal with this error counter. That's one thing, and then we've got to deal with this other thing. So I think what I'm going to do is a spot of duplication. I think we're going to take this and duplicate it, and then not do this, and then we're going to say if there's 0 things, there's nothing to do. Yeah, let's go. Yeah, no, don't like it. This is what I'm thinking. Something like this. And then we're going to take this. And then not do that. And then we're going to magically update these rules here. We're going to see how this goes. Well, since we've got this, we don't actually need to do the size here. Okay, fine. Let's try it. I'm just going to do it a really naive way to start with. Because I want to do. I think I want to do the fail fast approach on this to start with. If let count is mapping result dot len. If count is exactly 1, then do this. I don't know, maybe we should be doing pattern matching here. Right, let's see if this keeps the other test passing. Does work. That's good. So now we can go on to dealing with the other thing, which was using this. Right. And then we can go, I suppose, well, yeah. Well, we've got part map. Yeah, no, it's fine. We've got the part in the thing. It's fine. I was wondering how am I going to get the part. So then I suppose we can go I'm just going to write it in line, and then maybe there's this concept of like a rule hiding somewhere in this code, but we'll try and write it and then go from there. So we need to find the loadout item that matches the part that's in the mapping result. So we go let matched loadout item is loadout items dot, and then we want to get to a single one. So I think you go iter and then flat map or something. Is it flat map? Is it find map? We want an option of the type B, and the B is the thing that we're iterating over now. We've got an iterator that gives optional Bs, and then we return one of them. Oh, but we don't need to map it. We just need to find it. Yeah, I think it's just find. And then we go maybe item. And we go item dot muppen equals mapping result dot. Oh wait, what? Oh. We've got to iterate over it first. Let's do it the naive way to start with. We'll go for part mapping in mapping result. And then we can go part mapping dot. It's not really part mapping. Part dot muppen. So let's just create a reference to this temporarily because it's too long. We need to use it again. Extract to variable. And we're going to call it part. Mapped part, in fact. And this one isn't part mapping. This is part mapping result. Right, and then we go, this was this. And and the manufacturer is the manufacturer, right? So if it is that, turn true, but we need a semicolon. And if it's true, then you get something. You get an option. Now we've got a bit of a problem. In that if both of the parts are in the loadout, then we've got to deal with it. So I suppose we need to we're going to have to do something about that. So we're iterating over these mapping results, and we're going to go, yeah. So let's try this the slightly less naive way, because this returns an optional loadout item. We said so here, right? So instead of that, let's go let matched thing. It's the way you've got like a loadout as well as a part mapping result. And we're going to say dot filter and map. Do we want to filter and map it? So we need a reference to the thing. Yeah, because you could get errors. I'm not sure here. Now that I'm looking at this. Because the application rules could generate errors. This is a bit of a needle. This is a bit of a rabbit hole. This is mixing my metaphors. Yeah. So we're going to go filter map. Mapping results. So we've got our mapping result, which we can play with. And then we've got some code. And here we're returning an option of the thing. Okay, so this is supposed to be mapping result here. And we're returning true in order for this to return this option of whatever it is. If we take the semicolon off, and say thing for now. Currently this thing, I wanted a bracket. Are we supposed to be doing collect? Currently this thing is an option whatever, and if you map it, you're supposed to return you're supposed to return the thing instead of an option, but yeah. Can we go? No. Let's just see what the compiler says. Oh. Oh, well, yeah. That would make some sense. Type annotations. It doesn't know what we're trying to return here. It should do, because the type is known here. We don't want to return the option thing anyway. We just want to return something else. If there's some loadout item, we're going to return a tuple structure of a reference to the mapping result and the fact that it matched the loadout item. Which is already a reference. Otherwise, we return I don't know. Oh, tuple struct. Let's see what it says. Type annotations needed, yeah. Let's say you're going to get a vector of a reference to art mapping result or loadout item. Why not? Build a map. You're supposed to. How are you supposed to? What are you supposed to return here? Ours gives you a result. And then OK. What does OK on a result do? What does it return? it unwraps it. It's not clear, the documentation for this filter map. Should I be doing flat map? I can't remember all these API. Falling into my brain, continuing not possible. Yeah. Okay, let's not use filter map. Let's just use filter for now. But no, I need the mapping result. And I need the thing that it found. Part mapping result. Let's have a look at the error message in a bit more detail. So it says iterated item is whatever. This expression has a type of whatever here. Oh. Okay. Right. So I'm not going to deal with the unhappy case. I'm just going to deal with a happy case where if match things.length is exactly 1, then we're going to apply a rule, finally. We're going to say this is how we applied a rule before. And we're going to return as well. But it's not this rule, it's a different rule. It's like found in load out. Right? But we need the reference from the loadout. So we have to go loadout item. We have to find the loadout item. Loadout item is match things, whatever. The first one. Dot. And then because it's not really it's the second one of these because we're using a tuple struct, then we can get the reference out of it. And we're going to clone it. No. Right. Now we can add this. Why is... You need it. you do this? Like an anonymous struct. I can't remember whether you can or not. I don't like this because it doesn't tell you what. I mean, we could give it a reference to the loadout itself and then let the downstream display code deal with it. Not sure. Yeah. No. Okay, we're just going to put reference in it for now. I'm trying to go back to the code. Right, found a loadout. Right, so we've done this and we've got a rule and it applies. Who thinks there's anything else that we need to do to make it work? Me. Yes, because now we need to do this. Of course we do. We've got to write what we said we wanted in the test, didn't we? Don't we? We said that we want it to print out this. We don't need the brackets. Found in loadout. This, and then we've got the reference with this, which is going to be, oops, which is going to be reference. And this reference is the thing that's currently underscored here, right? Yeah, that might work. That might work. No. Okay, I mean, it sort of worked, but I think my test setup is wrong. Because we said we wanted the other one. Look, and it matched the first one. But at least we applied a rule, and it worked first time with the rule application, not test. So that's good, you know. Right. So we said this. Where's my loadout? Resistor feeder 1, manufacturer 2, resistor 2. Maybe it didn't work first time. Ah. Oh, yeah, no, I didn't get that right. There is one matched item, but I've applied the rule to the wrong the wrong thing. I see what I did. Whoops. Dear. Okay. Back to this. So there is one thing, it's true. But I used the wrong thing here. That's what happened. Copy and paste fail, that was. Because we're supposed to be changing this. But the problem is mutability. Because we said we got a mutable reference to art mapping. Oh dear. Right, we've got a mutable reference to these things. So let's go iter mut on here and create a mutable reference here, and that goes away. Don't know if it's going to compile. Yeah. Oh, no, okay. Okay, 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 okay. It's fine. Can I borrow it more than once? We're in a loop. No, everything's fine. Okay, now it might work. No, bugger. I mean, oh, look. At least that's right, though. Okay. Unresolved mapping conflict. That's not right. Yeah, that's because the thing that was applying the rules is checking this now. And it shouldn't be. Right. What it should be doing is looking at the applied rules. Doesn't need to look at the rules that are applied. It just needs to look at the result of the rule application process, I believe. I might be wrong on this. So this apply rules currently is returning whatever. So let's make this return a result of nothing and nothing. And here we're going to say, okay, nothing. Here we're going to say, okay, nothing. And then here we're going to say error, nothing. Right? Oh, we've got to return it. That would help. Right? And then now we've got this result which is not being used. So we get let rule application result, perhaps, is this. Right. Now, this error and this stuff. How can we do this? I mean, was I right in doing this? I think the process, I think this, yeah. Ooh. Let's have a look at this. So what we're doing is that we're applying a rule. But what we could be doing is not applying the rule, but returning the rule. But then it wouldn't know which one to apply the rule to. Yeah, no, that's a bit tricky. No then. No. Should the application of the rules be actually, should we just be finding the thing to apply the rule to? Should we actually be applying the rules? I don't know. There's quite a few different ways we could do this. Hmm. What are we trying to do here? So we've got this rule application result, which might be okay. If it didn't apply a rule, does this still make sense? Yes. If it did apply a rule, then we return it. Yes. But how do we deal with this multiple matching mappings thing? Do we... think perhaps we... I think this part mapping error is probably what this apply rules should be returning. It's a little bit funky, I'll give you that. You get a part mapping error or an okay. Let's try that. And then let's move the... Let's move this bit to here. And then we'll refactor it in a moment. If the count is 0, then you get this. If the count is 1, then you get this. Otherwise, you get this. And if you don't match anything here, then you get this. And then these were the mapping results. Right? Perhaps. A vector of part mapping result. A vector of part mapping result. Yeah. Not sure why it's complaining about that. We'll deal with it. And then we're going to go match rule application result. And we're going to say, if it's okay, then we want this. If it's an error, then we increase the error count by 1. And just return the error. I think. And then we need to assign that to this. And then delete all this, I think. What did I forget? Missing lifetime specified. Yeah, kind of thought we were going to get into this. Part mapping error. Mapping. This thing takes a lifetime. Match types. Multiple matching mappings. Result. I thought it already is a app result is a bollocks. What was this in here then? Part mapping results. Part mapping results is the vector of stuff, but this is a mutable whatever. Is it, do we need to, oh, wait a second. Do I just need to do that? Am I thinking about this wrong? No, let me read this properly. Why would it need a 2vec when this mapping result is already a vec? It's a reference to a vec. Do we? Is that going to consume it? Do we need them for anything else? If I did this, we don't have them anymore. Suppose we could just give them back. Or not. Yeah, that works. A bit funny. It does work though. Well, I mean, say it works. Oh, it does work. Well, that was quite a lot of code. Right, well, you know, what do we think about this? This is one of these like okay or whatever situations, isn't it? Should probably do a commit before I change this. I think this is supposed to be one of these. Let me just copy this, comment it out, paste it, dot. And I've got a map error or something, I think. Is error, that just turns true. We want to run a function and either keep what's in it in both cases. Is error and. Why did it return a true? Map error. And I think it's map error. But we're not really mapping it into anything. We just want to run a bit of code if that is what you're supposed to do. I struggle finding the right methods on these result things sometimes. Like, if there's an error, you get the things back in it, but you run the operation first. I think this is what we do. We just go error count plus equal 1 here. We don't actually care about the error. But it's now mapped it to a unit. So it's like, you know, it feels like if there's an error, do this and just keep the error back. Yeah. Like, clearly, it's like a fancy way of writing if blah, do this, right? It's like, I'm just going to assign it to it. What's the idiomatic way of doing this? And then just go if matching result is error, then this. I thought there was like supposed to be some nicer APIs to make that work. With this, you know, rather than repeating all this. I don't see it though. Is error. We've got a result. We implement, we've got some impls for it. We've got is error and. No. Does this only change the next function? No. No. Option. No. The. No. Asref. No. Asmot. No. Map. If it's okay, you do something. So it's not definitely not map, but we're not casting the error type to some other error type, changing it to it. Hmm. We're not doing what else? We're not mapping errors. We're not changing the error to something. Yeah. Inspect. Yeah. Calls a function with a reference to the contained value if okay. We want the same as inspect, but if it's only an error. Is there an inspect error? There is. There you go. That's what we're supposed to be doing. We're supposed to be going dot in Yeah, otherwise what does it return? It always returns self. Okay. Oh. Okay, dot inspect error. That's what you want. And we don't care about the error, but we want to run this statement and go semicolon at the end. I'm not sure whether that's valid syntax or whether I need little braces. There, that's what we want to do. Inspect error. Error. Learning. That's what I was trying to find. I don't care about the error. Everything's fine. Right, does it run? I think we just did that. It does run. Okay, all tests go. Hey, it runs. We're missing a unit test. We're missing a unit test. Yeah, we still got to deal with this. Done that yet. We're missing this. So while it does work, and let's just recap as to what we did there for a moment, so that we can align our brains. What we said was, if you've got a loadout, and the part you had, you have a mapping to, was found in the loadout, and print out this, apply the rule, and let it continue. So, okay, let's think about this. What does this tool do at the moment? What does this do? It basically prints out a bunch of stuff on the console, trace login, and a mapping result. Now we messed up all the console stuff when we introduced the tracing, and we introduced the tracing because we thought we were going to write a GUI app around this, but that turned out not to be the case. And now we've got all this tracing, and we've buggered up all the CLI output because we changed it to use trace instead of println. Yeah. Yeah. Feels like we need to do a commit though. Let's do the commit. What do? We variant builder. Match. Oh yeah, select mappings. Just thinking about what we didn't do. Select mappings. Select mappings if select a mapping if there is only one matching part in a loadout. Yeah, because if we had a loadout with two of them in it, we've got code in there which says no multiple matching mappings found. What we don't say is that both of these parts were found in the loadout. We don't say that yet. We could improve the error messaging around that. What I'm thinking is where we've got the part mapper and we try and apply the rules. If we saw that there was more than one here, we could do something else. We could return a different error here instead of that. So we could say something like multiple matching mappings found in loadout. And we could split the mapping results into the mapping results that weren't found in the... Oh, it'd be a bit of a faff though. That weren't found in the loadout and the ones that were. What I'm sort of thinking is that for any given mapping, there's not just a sort of like yes, no state for it. There's like a bunch of possible. Is there more than one thing that can happen to it? I don't know. I don't know. I think some of these things will fall out in the wash the more we start to use it. I don't know. I don't know. Mapping result. Let me check this. Mapping result is a part mapping result. You either get a part mapping result or a part mapping error. The part mapping result contains a part mapping and the applied rule. Right. But if there's sort of other information, let's look at the part mapping errors again. Multiple matching mappings. Now let's see how these are used. Yeah. When we use them, we add a bunch of mapping nodes to the tree and it prints them out. But if we said multiple matching mappings found in loadout, and we had a list of the ones that were in the loadout and a list of the ones that weren't in the loadout, then we could add specific mapping nodes. We could do something. Where do we put the... Oh yeah, we've got the chunks, right? And then we've got this applied rule. Yeah, this is what I was thinking. It's like... Let's go back to the test for a moment. Like if both of these... I guess you could apply the rule. This seems weird. You could apply the rule but still return an error. Let me think about that. Does that even make sense? I mean, but then you wouldn't apply the rule, really, would you? It's still an error. No, I think that'd be a pretty bad idea. Having more than one applied rule, more than one thing in the output that's got an applied rule to it. I don't know. Does that make sense? Load rules. Oh, we got to fix the name of this. Yeah, found in loadout. It's sort of like a rule processing result, isn't there? There's a lot of result things. There's a lot of stuff that can go wrong with all this, isn't there? Oh, it's crazy. Um, I don't know what to do on this one. Don't really know what to do about that situation. What I will do though is we'll go match so that we don't forget what the problem is. Dot len, and then it's going to be one is this. Otherwise, well, 0 is, I don't know, what did we do? That would end up with this. If nothing matches it, which is, and we've got this case already. Let's do it like this. Feel I want to move this into here so that it's clearer that we're dealing with that there. Otherwise you get this. Otherwise you get this. Yeah. Okay, let's rename this match things. Match. So this is part match to loadout item. Something like that, because we return a mapping result. Well, mapping result. Mapping results match to loadout item. If mapping results match loadout item's length is 0, then that reads weird. Then there's multiple matching mappings because we already checked it here. We could have a nested match thing. I don't really fancy that right now. We could break this out into a thing as well. There's the refactoring that we need to do here, clearly. Let's just make sure this works. That works. But it does indeed work. That's good. Okay. Select mapping if there's only one matching part in the loadout. Good. Right, let's check this. So we added the loadout. And we said what we want to happen. Found in loadout, feeder 1. Cool. And then we got rid of this to do. We're not asking the user. They're just going to change the state of whatever and then run it again. Okay. So in order to do that, we added loadout items. And then we added a way of loading loadout items using loadout item records, CSV loadout item records. And then we updated our variant builder to optionally load loadouts. And give the loadouts to the part mapper. And then apply a new rule which is found in loadout, but only if there's one. Right. Yeah. Let's just review this a little bit more. So we use loadout items, pass them over, apply the rules. That got unwieldy very quickly. Yeah, we've got the details of what it is. Yeah. This is where we pass it, the empty ones over. Yeah, fine. So like I said, we're missing a unit test for this. We should probably deal with that next, really. But that one is done. Let's look at our part mapper real quick. Close up the tabs. Right. So in our part mapper, we've got a bunch of tests which test the match mappings and so on. So if there was multiple matching mappings, we've got an integration, a functional test which checks this to see if they're in the loadout. No part mapping. So we want a test that's a bit like this one. We do need to come back and sort of refactor and deduplicate some of these tests, but today's not that day. Let's add this down the bottom. One in the loadout. Loading, loadout. That's what we want to do. And when we do some stuff, with some placements and part mappings and a vector of stuff. Now this needs to be different. This needs to be a reference to loadout items here. Okay, then we should have some expected results. The expected results is basically going to be the same as it was in the other test, but instead of it having an error, it's going to be the same as sort of like the first test where we apply a rule. Oh, let me undo that. Yeah, okay. Let me just keep that there for the moment. We're just going to say it's going to be okay, but with the vector of stuff, right? And the rule thing looks like this. Applied rule. One of them is going to be the thing that we want, which is going to be found in loadout with a reference 1. Dot to string. And then the other one isn't going to have a rule applied to it. Let's make the second one the one that's got the rule applied to it. Get rid of that. Right, so now we need the part mappings, for which we need 2, because we do. And they need to match the parts. Which are these same parts. And we also need same placement. But we need this loadout items now. And let loadout items, it's going to be a vector of loadout item new reference 1. And we said that we want to use the second part mapping which maps to part 2, which is this one. And then it's going to be O. Something like that. Why is this? Why complainy pants? Oh, not semicolon, comma. Duh. It's supposed to be reference 1 here. Dot to string. Dot to string. Dot to string. Right, so we've got loadout items. And I think what we should do is say that there's something else in the machine. And this is going to be manufacturer 3 and part 3. And that's going to be listed first for whatever reason. So we want to use reference 2 here now, because that's the one that we need to match against. Because otherwise it doesn't force us to iterate over it again. You could just return the first one. It needs to find this one in this list. So we said we wanted yeah, it's supposed to be okay, isn't it? Yeah, it's actually supposed to map this. This is a happy case. And I believe we just take this off, don't we? Because we're supposed to be just having a list of results, yeah. Closer, but not exact. What's wrong with that? Oh, that would help. There we go. Copy and paste fail. Okay, fine. Test expectation was wrong. So now we've got this extra test for that to say what we're supposed to get back. Right. Let's commit that. Add unit test. We add the unit test for mapping or multiple matching mappings where one part is in the loadout. There. Right. And the next one is going to be the case where there's multiple items that match in the machine and they're both enabled. It is quite an edge case, that is, because you don't normally have that situation. However, the code currently panics when this occurs because we added to do in there. Yeah, you see, we added this. What do we want to do? What do we actually want to do here? Hmm. Let's think about it from the perspective of the user. So we'll go back to the functional test. Right. Let's we're going to do this, and you might be like, "Oh my god, it's quite a crazy test now." Let's add R3 just for shits and giggles. And let's just do this just to see what it would look like. I'm not necessarily saying we're going to commit this, as you know, it's going to need to be a different value, and we're going to need 2 additional part mappings for it. Let's say 470 ohms, and we're going to say how many resistor manufacturers have we got at the moment in here? 1, 2. We've only got 2. Okay, so fine. So we can go 3 and 4. And we can say it's found in the machine and it's found in the machine, and therefore there is an unresolved mapping conflict. Is that what we want to happen? It probably is. Yeah. So, you know, this was fine. But this information here, this information here comes from the applied rule. So by using this same thing here, it means we've applied a rule. I mean, it doesn't, but under it could. So are we applying the rules to it? And then do we only return OK if there's only one rule applied in our other thing? Otherwise, we return an error of whatever type. And do we say, are we going to get more specific here? Like, no mappings found. Then perhaps here we say conflicting rules. Brackets. You know, and then this thing is the rule that was applied. Is it no rules applied? I mean, it's not very helpful, that. But it is sort of correct. Yeah, in this particular case, there wasn't any mappings to apply rules to. So yeah. Maybe no mappings to apply rules to. Yeah, just thinking out loud here. Okay, so I think I'm done for now. I need a little break, and then I might come back to this. But it is Friday afternoon, and it's getting on a bit, and it's too hot as well. It's baking in here. It's absolutely roasting. It's quite a nice day out, but it's hot. It's really hot. So I think I'm gonna call it there. So don't forget to click. I don't know. There's probably a like button somewhere down here. I suppose I'm not sure which side it is. I'm gonna have to look on this side or this side. I don't know. Anyway, click it. Go on, do it. You know you want to. And just remember, folks, it's only software. How hard can it be? We'll find out on the next one.